Alright, so I'm going to let you read these. I'm not going to read through this whole problem. I'm going to talk more about the problem, so please make sure you maybe pause the video and you're on this page and you read it, and then go ahead and play it. This video should be shorter because I'm going to allow you to do that. So you should have read this problem and realized these two people are trying to work together. You should read this whole page, by the way, the whole thing, even at the top. These two people are trying to work together to put all these stickers that are located around the rink. They're trying to put all of these stickers up on this hockey rink. So this is actually a real world problem. You guys see this at the hockey rinks and stuff like that. So here's the answers that we're going to go through. It takes the one team 20 hours to attach all the rinks, and it takes the other team 30 hours to attach them. However, their bosses asked them to work together. So just going through this, if we had 1 hour, okay, in 1 hour, how much of would the first team, they would be able to do 1/20th of the rink. If it takes them 20 hours to complete, that means that they are putting 1/20th of the rink up, because if you times this by 20 hours, you would get the 1/1, which is the full rink being completed. Well, how much would they have done in 5 hours? Well, that would be, your rate is, they're still working at 1/20th of the rate, but now they've had 5 hours, and so that would mean they get 5/20ths of this rink done, and so on. And the same thing with the second team. They do 1/30th. So 1 hour, they get 1/30th done. 5 hours, 5/30ths, which is 1/6 of the rink, and so on. So consider the amount of the rink that each team must complete in X hours. So basically what happens is however many hours they're working, it's how much they complete over 20, because it normally takes them 20 hours to complete. Whereas this team, if they work for 10 hours, they've completed 10 out of the 30, because it takes them 30 hours to do the whole thing. All right, so here's what happens. When we combine those two, we get how much it would be if they were working together. So when we are asked to actually solve the question, which is the big part, all that other stuff is just kind of the explanation of where we get all these x over 20 and x over 30. When we get down here, we are going to add those two together. And why does it have to equal 1? Because it is one rink that is going to be completed. And so, again, once we get to here, the rest of the stuff is what we've done before. The book always multiplies by the least common denominator. We've talked about how you could do that, or you can say, hey, the least common denominator is going to be 60, so you have to multiply this by 30, you have to multiply this by 20, and you have to multiply this by 60, and then just forget about the denominators. We've done it that way. Either way, it's going to work out to be this equation down here. Combine like terms, and you realize that it together will take them 12 hours to complete the rink. All right. Suppose the two teams work together and they only work 4 hours a day. Well, if it takes them 12 hours to complete, but they can only work on it for 4 hours per day, you divide that by 4 and realize it will take them 3 days to complete. All right. Shifting gears. This one took me a minute to understand, so please walk with me through this problem. Again, you're going to read this problem on your own. I'm just going to talk it. So if it takes Maureen 90 minutes to water the garden, when Maureen and Sandra are working together, they complete it in 40 minutes. So complete this table. So how much of the garden is Maureen going to water? Well, if she only gets 40 minutes and it takes her to do a whole garden, it would take her 90 minutes. So she works at a rate of 1/90, because every minute, now this is not hours, every minute she gets another portion of the garden done, and it takes her 90 of those to get a complete one. So she's working at 1/90th. So when I multiply those, because she only gets 40 minutes when they're working together, I realize that she is going to complete 4/9 of the garden. That's how much she's going to water. So if I had this garden and I broke it into 9 sections, she's going to complete 4/9 of it. It's probably a little more than that, maybe like that. Almost half, but not quite. She's going to complete almost half of it. So that means that Sandra is going to complete this other section. Well, what's the rate that she's working at? Well, we don't know. We don't know how long it would take her to complete the garden, so she's working at a 1 over x, because however many minutes it would take her to complete this garden would be our x in this case. Well, how long does she get to work for? We know she gets to work for another 40 minutes. Again, like we did up here, we're going to multiply those, and that's where they get the 40 over x. Again, when I add these two together, it's going to equal 1 complete garden being watered. So what they do is they solve for that equation down here by using the skills that we did. Now we know that x cannot equal 0. That's one of our restrictions. There's still restrictions in real-world problems. In fact, those are very important in real-world problems. So we go ahead and, again, you can either make common denominators. You can multiply by the least common denominator. If you notice, this is over 1, so the least common denominator is 9x. That's where they got this from. They completed it, and they get that it takes 72 minutes. Now, that answer, if you look, that is not 72 minutes for them to complete the garden together. Remember, together it takes them 40 minutes. This is how long it would take Sandra to water the garden by herself. So 72 minutes. All right, switching gears completely. Now we're going to those solution problems. I'm sure you guys have seen these types before. So again, Manny is taking the college chemistry course. He needs something that has 2%, and all he's got is he's got 200 milliliters of 10%. So if you think about that, when you do that, if it's 10% salt, that means that it's 90% water. So 90% of this is water, 10% is salt. So when you take, remember you're not allowed to multiply by percentages, so they take this right here, that 0.1 is really the 10%. Remember, you change 10% into a decimal, they multiply it by 120, and they realize in that solution there is 12 milliliters of salt. To figure out how much water there is, they take the rest over, which is 90%, which is water, and they multiply it by the 120. Remember, change it to a decimal, and they realize that there's 108 milliliters of water. And again, if you add these two numbers, you get 120 milliliters. Okay? So, they want to know how much could he do, what would he do in order to get 2%? So let's just do some stuff. What they did here is they're just showing you how if you take, and you're still going to have, we're still always going to have 12 milliliters of salt. Since we need to bring that down, because it's 10%. It's 10%, right? We want it to go down. We're going to add more water so that the solidity goes down, where the salt content goes down. So we're going to take that 10 and get it down to a 2, so that means I need to add more water. So down here, we realize that it's 12 over 120. That's how much of the how much salt compared to the total amount. Well, if we add more water, we are not going to be affecting this 12, we're only going to be affecting the total amount. So down here they show you when you add, let's say, just 80 milliliters of water, and then you do your division, take 12, divide it by 200, you get 0.006. As a percentage, that's 6%. Okay? What if you added 180? Well, you're only going to add that water, you're not going to add any salt content, so you're going to have 180 added down here, and that's going to make it 4%. If we wanted to figure out to what he needed, which is a 2% solution, we're going to set it up as an equation. We're going to say, how much water do I need to add to this 120 milliliters to get it down to be 2%, which, remember, how do you change to a decimal? You get this rid of this, and you move away twice. And so that's how they got that 0.02. And we know that x is not allowed to be a negative 120. Now, that just means we can't take the whole solution out and have that. So anyways, it's no big deal. It really doesn't have, we're going to be adding water. So my restriction doesn't really apply here too much. But anyways, they then realize hey, you can do this a couple different ways. You can put this over 1 and cross multiply, which is what this book did. They took this and times it by this and times that by that. That's how they got this step right here. They then distributed this number and got this down here. They then move this 2.4 to the other side, so they minus 2.4 on both sides, cancels out, minus 2.4 on this side. They get this, divide by 0.02 in the calculator, and boom, they realize they're going to have to add 480 milliliters of water to make this 2% solution. All right. All right, so this is where she's got two different percentages. She's got a 20% sulfuric acid content. She's got a 5% sulfuric acid. And what she's going to do is she's going to mix them to make a new one. And so we know the new one would have to fall between 5% and 20%, because even if she doesn't add any to 20%, she just keeps it the way it is, it's going to be 5%. Even if she doesn't add anything to this, it's going to be 20%. When she starts mixing them, the 20% is going to bring that 5% up. So I know it's got to be between there. All right, so suppose that the 20 milliliters of 20% is mixed with a 10%. Oh, yeah, sorry. 20. So we have 20 milliliters of this at 20%. She's going to mix it with 10 milliliters of 5%. What is the concentration? Okay, so again, we go through this. With 20 milliliters of water at 20%, okay, she's going to have, again, you take the 20%, times it by the amount you have, and it tells you that there's 4 milliliters of sulfuric acid. You then take that 4 and minus the 20, how much you have, and realize that there's 16 milliliters of water. So in this 20%, she's got 4 milliliters of sulfuric acid, and she's got 16 milliliters of water. And together, those combined make her solution of this. Now, she's going to do the same. We're going to think about the same thing with the 10. She's got 10 milliliters of 5%, so she's got 0.5 of the sulfuric acid for this, and she's got 9.5 of the water. Now, what would happen if she adds those together? Well, you're going to get the concentration of sulfuric acid, the 4 milliliters, and the 0.5 milliliters. Those are going to add together because those are kind of like terms. They're sulfuric acid. So she's going to get 4.5 sulfuric acid milliliters to the water, which she has, not the water, I'm sorry, that's wrong. This is sulfuric acid over the total. How much is in total, not just the water. So really, we don't even need to do this part right here for this problem. Maybe later on that'll have some kind of impact, but right now we don't really need that information from what I can tell. We just need the total amount, which is the 20 milliliters, and the 10 milliliters, so she's going to have 30 milliliters, and of that 30 milliliters, 4.5 of it is going to be sulfuric acid, so she's going to have a 15% solution. All right, write an equation and solve the amount if she wanted it to be 12%. So we know that she's going to be taking the 20% and she's going to be diluting it with the 5%. So that means she's going to have this set amount of the 20%. She's not going to be changing that. So if you notice down here in our equation, she starts with the 4 and she starts with the 20, because we know we're going to have that. We know we're going to have 4 over 20. Now, what are we going to add to it is we're going to add 0.05x. How much of that are we going to, and then over how much are we going to add of that solution? And remember, it's 0.05 because that's how much the percentage is of this solution. So that will say that she's going to add, if she's adding 20 milliliters, she's only going to add 0.05 times 20. That's how much sulfuric acid will be added. So that's where this equation comes from. Again, this book throws this over 1 and cross multiplies, and they realize that it's going to be 22. Again, we'll have practice on this tomorrow in class. We'll go through these. You can stop this video. I made it shorter so you can read through this and look through these answers and see where they got these numbers from. Hopefully that will help you guys out, and we'll practice, like I said, tomorrow. Remember, test is going to be Thursday. All right, have a good night.